Welcome to this presentation on the smart way of troubleshooting SQL Server clusters and availability groups outages. My name is Edwin Sarmiento. I'm a Microsoft Data Platform MVP and a Microsoft Certified Master for SQL Server. If you have any questions regarding the presentation, you could send me an email, you could connect with me on Twitter, on LinkedIn, and you can visit my blog for additional information. Now, I want to start off by saying I'm a realistic optimist. And what do I mean by that? Every time I get called into a customer engagement, I always start off by saying Murphy's Law or mentioning Murphy's Law, that anything that can go wrong will go wrong. Now, I'm an optimist. It's just that things really just happen. There are systems that will go offline because they're systems that were designed and implemented by humans, and we can make mistakes. And understanding that these things could happen can help us get ready. Now, before we go even further, let me ask you, have you ever been called in to troubleshoot an offline SQL Server Failover Clustered instance or even an availability group, but you felt clueless? Not knowing what to do. You felt so lost. You don't know how to start, where to start, when to start, what to do. Have you ever been in that situation? What about this? Have you ever wasted hours, again, trying to bring a SQL Server Failover Clustered instance or availability group online, only to realize that it has nothing to do with SQL Server? Or what about this? Have you confusingly deciphered the cluster error log because, well, that's what you were told to do? Troubleshooting an issue that involves failover clustering, you were told to look at the cluster error log. Now, the key thing here is preparation. You want to be prepared when these things happen, and this presentation is meant to guide you in that process so that when that time comes, you will be ready. And I want you to focus on the main goal. The main reason why you are running SQL Server workloads, for instance, their failover clustered instances or availability groups, is because you need high availability. And that is the main goal. And we want to understand how Windows Server Failover Cluster works in the context of SQL Server. In fact, if you understand this concept, you can deal with any type of workload that's running on top of a Windows Server Failover cluster, be it Microsoft Exchange, Microsoft Hyper-V, and any other workloads for that matter. I used the traffic light analogy to explain how a Windows Server Failover cluster works. In a Windows Server Failover cluster, you have two or more nodes to provide high availability to a workload. In this case, it's SQL Server. At any given point in time, the workload is currently running, actively serving client requests. If something goes wrong, a hardware failure, power failure, a blue screen, the service is stopped on the node that is currently running it. The failover cluster will then have to wait for any of the available nodes to be ready to pick up the workload to then eventually start the service on that node. Let's illustrate this stop, wait, and start service using the traditional two-node failover cluster. And the reason I'm using this as an example is because it's been there ever since. In the good old days of Windows NT4, SQL Server was one of the very first workloads that was designed to run on top of a failover cluster. Now, let's illustrate the stop, wait, and start process, the traffic light analogy, using the traditional two-node cluster. We've got two nodes. The node on the left is currently running the SQL Server workload. Client applications are connected to it, sending transactions, inserts, updates, deletes, or any data modification. And then let's assume that something happened on the server on the left. That's what the stop service happens. The service is stopped from the node on the left, and then the cluster will then wait until the node on the right is ready before it starts the service at that point. Notice that the client applications got disconnected when the service was stopped on the node on the left. The client application can then start reconnecting back to the SQL Server workload, in this case, the SQL Server service. It could be a failover clustered instance, it could be an availability group, but the client application can now reconnect back and continue on with sending transactions to the database. Whether it's, again, a failover clustered instance or an availability group, the principle and the concept applies. Let's look at some definitions here and understand the different components that make up a Windows Server Failover cluster. This will give us a better understanding when we start troubleshooting issues, particularly outages, with a failover cluster. Let's start with resource. A resource is a hardware, a service, or an entity that is hosted on the cluster. In our case, we'll look at a service. This is SQL Server. Now, that could be any other resource. It could be a network resource. It could be a disk resource. It could be a virtual IP resource. A resource forms the basic building block in a failover cluster. When you present a resource to a failover cluster, the failover cluster will then take ownership of that resource and manages how that resource will behave. In our case, SQL Server. Will SQL Server be started? Will it be stopped? Will it be moved between nodes? That resource is owned by the failover cluster. Then we have the concept of a resource group. And the way I look at it is that the resource group is a combination of resources that are managed as a unit. Now, I kind of think of resource groups just like utilities and services that you have. Let's say, for instance, that you have a cell phone and you're moving to a different city or maybe a different state or maybe a different country if you want to do roaming. When you move to a different address, you need to tell the service provider that they have to change the mailing address for those bills. Otherwise, maybe after 3 or 4 weeks, the service stops because you're not getting the bills and therefore you're not paying for your bills. So when you move, you don't just take the service and the utilities with you, you take the bills as well. And in order for you to take those bills with you as well, you have to inform the service provider of the change in billing address. Now, resource groups are, again, a group of resources, and I like calling them resource groups because, they make sense. They're a group of resources. Although in Windows Server 2008, Microsoft started calling them services and applications, and in Windows Server 2012 and higher, you will see them being called as roles. Regardless of how Microsoft calls them, the concept still remains. They're a group of resources. That's why I like calling them resource groups. Now, let's draw some parallels between a standalone instance and a failover clustered instance. If you have a standalone SQL Server instance, everything sits in a single machine, and you could look at the logical boundaries that involve the storage, the SQL Server service, the host name, the physical IP address as resources in a resource group. When you look at a failover clustered instance, you're looking at all of these, the virtual server name, the virtual IP address, the SQL Server resource. In this case, it's not just a service anymore, but a resource, and the underlying shared storage combined together and make up a resource group. And when you're dealing with an availability group, it's basically the same concept minus the storage. You don't have shared storage in an availability group. Next, we look at the concept of a failover, and failover is moving a clustered resource from one node to another, illustrating the point earlier when we were talking about the traffic light analogy. When you are moving your SQL Server workload, again, be it a failover clustered instance or an availability group, from the node on the left to the node on the right, that is a failover. Now, whether it's the failover cluster initiating the failover through automatic failover, or you, the administrator, moving the workload manually, maybe as part of a maintenance, you are invoking a failover, which means moving the resources or the workload from the node on the left to the node on the right. Then we have the concept of dependencies. Dependencies are the reliance of a resource on another resource. And let me use, again, drawing parallels between a standalone instance and a failover clustered instance. When you're looking at dependencies, you look at one service not starting because the service it depends on needs to be started first. Let's look at SQL Server Agent. If you've worked with SQL Server for a long time, you know that you cannot start a SQL Server Agent unless the SQL Server service has been started. This means that the SQL Server Agent is dependent on the SQL Server service. In a failover clustered instance, the SQL Server service or resource is dependent on both the shared storage and the virtual server name, which means in order for me to bring the SQL Server service online, the shared storage has to be online and the virtual server name has also to be brought online. If any of these two, the virtual server name or the storage, isn't available, I won't be able to start my SQL Server service. Now, the virtual server name is dependent on the virtual IP address, which means if I need to bring the virtual server name online, I first need to bring the virtual IP address online. And this, again, with the concept of the resource group or the role, form the foundation of how I deal with and how I start with my troubleshooting processes. I will use this information of the dependencies, the resource groups, the different resources that are part of that group as the foundation for troubleshooting outages. So when I get a phone call that a failover clustered instance or an availability group is offline and I need to bring it as quickly as I possibly can, I start off with this. Now, effective troubleshooting, since this is a session on troubleshooting outages for failover clustered instances and availability groups, knowing how it works, which is why we started off with how a Windows Server Failover Cluster works, because that is the key to effective troubleshooting. Now, when you're troubleshooting an outage, and again, just a quick reminder, when we started off, we understood how important it is to bring the failover clustered instance or availability group online in case of an outage. The goal, again, is to bring it online as quickly as you possibly can. Now, as engineers, we may fall into the trap of trying to find the root cause. Please, don't find the root cause. You do root cause analysis after everything is back to normal. You know, when the users are happy, the system is up and running, and everything is back to normal. That is when you dig into the root cause. But while you're troubleshooting this, whether again it's a failover cluster or the availability group, bring it online as quickly as you possibly can. That is the goal. Now, when you encounter a problem or an issue that is causing an outage, or maybe again, the failover cluster went offline, the availability group went offline, ask yourself the question, is the failover cluster available? And the way to check this, very simple way to check this, is you do a ping or telnet on the virtual network name. This is the virtual network name of the failover cluster, not the failover clustered instance, not the availability group listener. So do a very simple ping or telnet test. So if the failover cluster name is, let's say, cluster 1, do a ping on cluster 1. Checking if you can log in, maybe launch a remote desktop session and connect to it. This is the first step. Now, if the cluster is available and the failover clustered instance or the availability groups are still offline, this is where you start with what I call the 5-step process for troubleshooting outages. Number 1, review the dependency report. Look at which resource is offline and check if there are any other dependencies. For instance, if you're dealing with a failover clustered instance, check, is the network name or is the virtual network name online, or is the shared disk online? Because if any of those two are not online, then the SQL Server resource will not come online. If you're dealing with an availability group, if you're using a listener name, for instance, and the listener name is not online, then the availability group will not come online. Now, recall this graph or this image that we looked at earlier. Remember how the dependency impacts the availability of the resource. So if the virtual IP address goes offline, immediately the virtual server name will also go offline regardless of whether it's healthy or not. If the virtual server name goes offline, the SQL Server resource will go offline again regardless of whether it's healthy and fine or not. And of course, when the SQL Server resource goes offline, the SQL Server agent will also go offline. I call this the domino effect because just by causing an issue or just by the virtual IP address experiencing an issue, everything else would follow and everything else will go offline. This, again, just by looking at one resource becoming unavailable will cause the entire resource group to go offline. Like I mentioned earlier, this explains my entire troubleshooting methodology. When you look at the cluster dependency report, and this is something that you could generate off of the failover cluster, you could look at the dependency report for the resource groups running on top of your failover cluster. In this case, I can see that in order for me to bring the SQL Server resource online, I need to have the network name SQL test to be available and the physical disk DB disk to also be available because of the AND logic condition. Both the network name and the physical disk have to be online in order for the SQL Server resource to be online. And when you're bringing all of the resources back online, it's also kind of like the domino effect, because the clustered resources without any dependencies will be the first ones to come online. In this case, when you bring the whole resource group online, the virtual IP address will come online first because it does not depend on anything. After the virtual IP address comes online, the virtual server name will then come online. Next will be the SQL Server resource, and finally, the SQL Server agent. Now, in terms of the availability groups running on top of a Windows Server Failover cluster, this is how the cluster dependency report would look like. You won't be able to bring the availability group online unless the network name is online and consequently unless the IP address is online. So when you look at the dependency report for an availability group, you would start off by bringing and making sure that the virtual IP address is online, and then bringing the network name, or rather the listener name, availability group listener name online before you can even bring the availability group online. Now, before I even look at the Windows event log, I start off with the dependency report, because if I know the issue has nothing to do with SQL Server, I won't spend any more time trying to fix the issue. If it's a network name issue, I'll call the network guys or the systems administrators or the Active Directory guys or the people responsible for the DNS. If I know the shared disk is the one that's causing the issue, I'll pick up the phone and call the SAN administrators. It is an effective way of trying to figure out what the problem is as fast as I possibly can, and bringing in as many people who are responsible for the system to quickly resolve the issue. Now, if I know that there is something wrong with either the network or the storage, I would start digging deeper. Well, of course, after informing the people responsible for that particular issue. Within the Windows event log, I will look for failover clustering and level equal to error. You could navigate through the Windows event log to find out what has caused the issue. You can look for error messages that pertain to, for instance, if it is a problem with storage, I will look for anything that is related to storage. Now notice that it is only at this point that I start looking at the SQL Server instance, even though I am responsible for it. I only look at SQL Server if I know and I'm pretty much sure that it is a problem with SQL Server. Now, when I know that it is a SQL Server problem, I look for clues. Like for instance, if it is a failover clustered instance and it is offline, I start looking at potential causes within the SQL Server error log. And in this case, I would treat it as if it is a standalone instance. For instance, if the system databases are not online or they're not accessible, if the folders do not exist, if the database files are corrupted, I will treat them as if it was a standalone instance. Now, if it is an availability group, I will look at the SQL Server error log and look at these two keywords. The first one, resolving. Error 983 is an example of this. Unable to access database because its replica role is resolving, which does not allow connections. Now, in this case, I know there is something wrong with one of the replicas and I have to fix it. The second one is failover. In this case, the example is error 19406. The state of the local availability replica in availability group has changed from one state to another state. The replica state changed because of either a startup, a failover, or a communication issue or a cluster error occurred. The only time that I look at the cluster error logs is when I identify that it may be something wrong with Windows or SQL Server. I've looked at the dependency report. I've looked at the Windows event log. I've looked at the SQL Server error log, and I don't have any other option. In fact, I tell my customers, if you're already looking at the cluster error log, you are in big trouble, which prepares the way for step number 5 later. But in this case, I would like to point out that this should be your last option, not the first. So if you've scrambled trying to decipher the cluster error log when an outage occurs on your failover cluster, you're doing it wrong. This should be the last option. Now, in case you find yourself trying to read the cluster error log, there's a couple of ways to read the cluster error logs, and you have to look for errors before and after events that led to the issue. So how do you read the cluster error log? A couple of ways is one, by looking at the diagnostics event under failover clustering. In my case, I use the get cluster log PowerShell commandlet to generate the cluster error log for all of the nodes in the failover cluster. By default, the logs are in GMT, so what I do is I use the use local time parameter so that it will generate the cluster error log with the reports or the events written in the local server time. Now, like I said, in case you end up reading the cluster error log, here's how you read an entry in the cluster error log. You start off by looking at the first few characters before the dot, which is the process ID. This is the process that caused this event. It could be SQL Server. It could be any of the resources running on top of the failover cluster. The second one is the thread ID. The thread ID that could be a part of a single process that led to this particular event. Next is the date and time. Like I said, by default, the date and time of an event would be in GMT unless you generated a cluster error log using the local server time. Next, this will tell you whether this is an information, a warning, an error, or a debug message. The DBG message is rare unless you turned on verbose logging in the cluster error log. Then we'll look at the resource type. Is it the SQL Server cluster resource? Is it a physical disk? Is it a virtual network name? You would identify what this event is by looking at the resource type. Then we have the resource name, and the resource name is how you name that resource on a Windows Server Failover cluster, which of course tells us to name our resources appropriately to make troubleshooting easier for us when an issue occurs. And then you have the description for that message. Note that the description, of course, ties into the event generated by the cluster error log at that point. And like I said, reading the cluster error log should be your last resort. You don't want to be bombarded with so many messages and so many events trying to figure out what went wrong when the cluster dependency report can easily tell you what is offline and then immediately take action by bringing that resource online. Now, when you encounter a problem or an issue, the first question we asked earlier was, is the failover cluster accessible? And the first 4 steps that I've outlined is something that you would do if the cluster is available. Now, what if the cluster is not available? Well, you could force start a cluster without a quorum. In fact, I've written an article on MS SQL Tips a couple of years ago on how you could force start a Windows Server Failover cluster without a quorum. Now, you could use this for both failover clustered instances or an availability group. But the point is, you only force start a cluster only if you are sure that the Windows Server Failover cluster is not available. Now, people laugh at me when I tell them this because the reality is, if you cannot solve your problem or your outage within a specific period of time, you don't want to be going past your recovery objective. If your recovery objective and your service level agreement is, let's say, 4 hours, and you're already at the 2-hour mark, don't hesitate to pick up the phone and call Microsoft, because again, your goal when you're dealing with an outage is to meet your recovery objectives and your service level agreements. This is not the time to play hero. This is not the time to play the big guy who tries to solve the problem, because that is not the goal. The goal is to bring the failover cluster as quickly as we possibly can, which is why if you know that you are going past your recovery objective and your service level agreement, pick up the phone and call Microsoft to get help. I've outlined the process that I used when troubleshooting outages involving SQL Server Failover clusters and availability groups. It's a very simple process that anyone can follow without having to be pulled into the rabbit hole and trying to figure out what the problem is before we've gone past the recovery objectives and service level agreements. Start with the dependency report, and then using the outcome of the dependency report, you look at the Windows event logs, you look at the SQL Server error logs, and then finally look at the cluster error log. If any of those 4 steps within the process is not giving you any answers or is not helping you bring the cluster online, call Microsoft. Those are the 5 steps that you could use to troubleshoot SQL Server clusters and availability groups outages the smart way without having to scramble around trying to figure out what went wrong. And like I said, if you have any questions, feel free to send me an email regarding topics and concepts that I've covered in this presentation. And I hope you found this presentation valuable. Thank you for watching.